this next result now. So if last time we compared the mean of the sample and of the population when we had taken only one sample. So in this case we are taking two samples from two different populations. One sample each from one population. So we have two different populations and one sample from each of the population, right? Okay. So let us see what's the theorem now. So if an independent samples of size n1 and n2 are drawn from at random from two populations, discrete or continuous, with means mu1 and mu2. Okay, mu1 and mu2 having variances sigma 1 square and sigma 2 square respectively. Then the sampling distributions of the difference of the means. Okay, you take different samples and you take the difference of the means. Then the difference of the means has the mean as mu1 minus mu2 and variance as sigma 1 square by n1 and sigma 2 square by n2. This difference actually follows the normal distribution, standard normal distribution, which is going to be given by x1 bar minus x2 bar minus mu1 bar mu1 minus mu2 divided by this root over sigma 1 square by n1 and sigma 2 square by n1. If you notice this thing, this expression over here is nothing but the mean over here of the difference, and the denominator here is nothing but the standard deviation of the difference. Okay, that's what I had written here. Okay, so let us see a problem on this now. Let us see this problem here. Write down the question now. What? I know. What I said to you? I'm just looking at the curtain. So the mean score for freshmen on an aptitude test at a certain college is 540. So the population mean is 540. That's what they're saying, with a standard deviation of 50. So the population standard deviation is 50. Huh? Assume that the means of the to be measured at any degree of accuracy. What is the probability that two groups selected at random consisting of 32 and 50 students respectively will have their mean scores differ by 20 points, and B is an amount between 5 to 10 points. So let us solve this problem now. Okay, so it's given to us that the population mean mu is equal to and the standard deviation is given as population. Okay, so now two samples are taken. Of sizes N1 is equal to 32 and N2 is equal to 50. Okay. So now let us talk of the difference over here. So mu of x1 bar okay, so see, we have taken the samples from the same population. Okay, write this word same over here and highlight it. Okay, so both these things have been taken from the same population of sizes 31 and 50. Okay, okay, so the population is same, that's why we are getting this here as same. Okay, now with regard to the sigma square of sigma 1 square upon n1 square plus sigma 2 square upon now see sigma 1 and sigma 2 are the same things. Sorry, this is not square in the denominator. N1 is taken as 32. Let me just calculate this on a calculator. Okay, so this is 78 point. This is 128. And square, this is square now, so square of this thus square root of this quantity, which is going to be used in the formula, $11.31. It is 319. Okay, so this is the thing. Okay, so this is done. The mean is 0 and the variance is 128. Standard deviation is 11.3192. So now the question is given as what is the probability that probability of x1 किधर गो this is probability of this is the question. Okay, so now so define z to be equal to on this z is equal to x1 bar minus x2 bar minus mu1 minus mu2 sigma 1 square by n1 plus sigma 2 square by n2, right? So now in our case the small z is equal to 20 minus 0, this was calculated as 0, and this is 11.3192. Okay, so 20 divided by 11.3192 1.76. So this rounds up to 1.77 now. So now, so thus 'Okay, after changing the thing or variable from x1 bar minus x2 bar, this becomes, so this is going to be equal to कौन को यार पुढे अरे कोणा बरोबर सेट असा तुझा कोणा बरोबर सेट असा तो सांगूक जाय ना आजकालची भुरगी Okay, done. I'll go to the table. Actually, I'll refer to the table from my book only. 1.77. $96.16. One minus 0.9616. Huh? 384. Okay, so this is the thing. So thus there is only difference huh huh can't promise. What is going on there? You're having a stand-up performance or something? What are you doing over there? I thought you're performing or something over there. Okay, next part of the problem. B part of the question is I removed the pen out. B part of the question actually means that it varies between 5 to this is the question in B part, right? Okay, so let us now measure this. Z1 is equal to going to be 5 minus 0 upon 11 point, what is that number? I'm using this formula, by the way. I'm not writing it down again. Why? I will solve this problem at least now. It will take only 2 minutes more for this problem. तू सांगला म्हणजे तात्याने सांगला दिसणार होता. 4 4. So this becomes 0.44 and this becomes 88. Okay. So thus 0.88. Zero point 488 8106 8106 and this is 44 67 11 So thus fourteen point 60% chance. 60%. Difference between the difference between the means differ. Difference, spelling mistake. हाँ मागे बरोबर काय नाही अंदर ओके next problem. A random sample of size 25 is taken from a normal population having mean 80 and standard deviation of 5. Another sample is taken, random sample is taken of size 36 from a different normal population having mean 75 and standard deviation is 3. Find the probability that sample mean computed from 25 measurements will exceed the sample mean computed from the 36 measurements by at least 3.4 but less than 5.9. Okay, so let us try to do this one now. Okay, so here we have two populations. The first population is mean 80, standard deviation 5, and the size of the sample is here is 25. Here you have mu 2, and 3 is okay. Now let us calculate all these terms. So thus that's why they are very happy when you are not around. Okay, and you have a sigma square of x1 bar minus x2 bar. This will be equal to 36. Mm, this is 1. This is 1 by 4. So this will become 1.25. Okay, so now, and this is 5 by the way. X1, X1, sorry. So the question now is, find the probability that this is the question to be found. Okay. So now, since there are two numbers here, Z1 will be 3.1, sorry, 3.4 minus 5. Okay, and that answer is 1180. Okay, so this will round it up to okay, approximately this, and Z2 5050. Okay, 0.0. Okay, now I'll refer to the table. Uh, 0.8. 0.8 is 7881. 1 point 0.14. So 0.14. 0.555. Triple 57. Okay, done. So probability will lie between these two values is this. Okay, so we'll stop with this today because I have to start with the next subtopic now. Others I can start if you want. Nice colorful pictures are there.